everyone. Welcome to Stats Rescue 911. My name is Lynn, and in this tutorial, I'm going to show you how to run and interpret a one-way repeated measures ANOVA. Sometimes this is just called a one-way repeated ANOVA, or it might even be referred to as a one-way within subjects ANOVA. I'm also going to show you how to run and interpret a form of post-hoc test in the event that the ANOVA is significant. Before we get started, it would be really helpful if you knew or were familiar with the following terms, and that is between versus within subject factors, how to enter factors or independent variables into SPSS, how to enter dependent variables, DVs, into SPSS, what post-hoc tests are and what they are used for, and then finally, why error bars and confidence intervals. If you are unfamiliar with these topics, you can still follow along with the video. It's just that you may have a more difficult time understanding what's going on, and I will try and explain, but again, it's better if you know these terms in advance. Check my YouTube channel to see if I have these topics listed. If not, they'll be coming soon. All right, so before we start with the analysis, give this some context. I did a survey with my students a number of years ago, and we surveyed participants on campus. We asked them, among other things, we asked them whether they believed in angels, demons, and extraterrestrials. We wanted to know if this might affect their whether or not they love, like, or hate horror movies, and we also wanted to know if this would impact how much fear they experience. But in this analysis that we're going to be running, we're looking at the effect of the different types of unknowns, like angels, demons, and ET, so those we'll just call the unknown. And there are three different levels that we're going to test, and we've got angels, demons, and extraterrestrials. And we are going to look at whether or not people believe more in angels, for example, than demons, or whether people believe the most in extraterrestrials. And so we're going to need to run a one-way repeated measures ANOVA. It's one way because we have just one independent variable, and that would be the unknown, and it has three or more levels or categories, and in this case we have three. All right, so that's what makes it a one-way, the fact that we have one factor, and it's a one-way ANOVA because we have three or more levels. Now, it's a repeated or within subjects ANOVA because everybody answered the question about angels. So everybody was in this group where they generated a belief score. We asked them to what extent they believe in the angels. Same thing here. Everybody was asked the question about demons, so they were in this group as well, and they provided us with a belief score. And then the same thing with extraterrestrials. All right. So now let's bring up the data set so that way we can begin the analysis. So let's see. Let's first look for, right here. These are the different categories of our within subjects variable. So the belief category, we have angels here, demons, and extraterrestrials. Whenever you have a within subjects independent variable, to actually get it into SPSS, to enter that variable, you're going to have, in variable view, you're going to have to designate a row for each level of the variable. So even though my variable was one variable, and that was the belief category, each level has its own row, and this is in variable view. Okay, let's go back to data view. We've got the three columns to represent the three different groups, and we want to run the ANOVA, so we're going to go to Analyze. Then we're going to go to where it says General Linear Model, and we're going to go to where it says Repeated Measures. Now the default, well, let me reset here. The default name for the within subjects variable is just factor 1. But I advise you to change that because on your output, if you see something that you recognize, a name you recognize, it'll be a lot easier to interpret. So let's call this belief, and then underscore, because SPSS doesn't like hyphens or spaces, belief category. And remember that there are 3 levels. We need to type in a 3. If you have 4 levels, type a 4. If you have 5, you type in a 5. Now hit add. All right, now the next step is to tell SPSS what the 3 levels are. So to do that, you go down here to define. And you can see it's asking what is level 1, level 2, level 3. So that's where you just move these over. So angels was level 1, demons level 2, extraterrestrial level 3. Okay? Now we have a bunch of options over here on the right. Let's click on plots so that we can get a graph because, you know, a picture's worth 1,000 words, right? We're going to move the categories of the independent variable. The belief categories are going to be on the x-axis or the horizontal axis. And we don't have to tell SPSS to put in a y-axis with belief scores represented on the y-axis. It will do that automatically. You just need to define the x-axis. Now we hit add. If you don't hit add, you're not going to get a graph. And then you can choose between a line chart and a bar chart. I'm going to choose bar. And I want to include the y error bars, so I'm going to choose that. And here you can choose between the y error bars being generated using confidence intervals, and here it's the 95% confidence interval, or you can choose to put y error bars using standard error of the mean. I'm going to choose the 95% confidence interval. And this just means that when I look at those y error bars, and they're going to be found for each mean, so for each group, you're going to have a confidence interval. The 95% confidence interval just means that within the upper and lower limit of the interval, 95 times out of 100, we would expect the true mean, mu, to be in that interval. All right? Again, these are things that I'm hoping that you're already familiar with. All right, so now hit continue. And the next place we'll go, now you might think that we want to click on this post-hoc test, because if our ANOVA is significant, all we're going to know is that there is an effect. We're going to know that at least 2 means are different from each other, but we don't know which means are different from each other. All we know is that there's something there, not where it is. So a post-hoc test is going to tell us which means are different from which, but you don't click on post-hoc. All right, I know that doesn't seem right, but with a one-way repeated ANOVA, you need to go here where it says EM means. So click there, excuse me, and we are going to move our factor, which is the independent variable, over here where it says display means 4, and then we're going to click on this, compare main effects. And you'll notice that LSD none is going to auto-populate, and that's fine. You can leave it like that. But essentially, by clicking on compare main effects, we're telling SPSS to run the post-hoc test. All right, and it's going to do the equivalent of an LSD t-test. Excuse me. I've been teaching a lot today. All right, so we're going to run these post-hoc tests by clicking on compare main effects. Now we're going to hit continue. And the post-hoc tests, remember, they'll tell us which means are different from which. Now we're going to go to options. And the ones that you're most likely to use are descriptive statistics, estimates of effect size, and that's pretty much it. You might be familiar with a one-way independent ANOVA, and in that situation, we would select homogeneity tests. but that's because homogeneity is an assumption of the one-way independent ANOVA. It is not an assumption of the one-way repeated. So don't select this. You can, but you'll just get an error result. All right, now we're going to hit continue. And then for a grand finale, we're going to hit OK. And here are the results. If we look at this first box here, it's telling us that we tested a within subjects factor. I always like to go here and verify that I ran the ANOVA on what I think I did. And it tells us that we have 3 levels: angels, demons, and extraterrestrials. All right. We're looking at belief scores. That's not written here, but that's what we are looking at. And then this box tells us what the mean was for each of our 3 groups, the standard deviation, and the sample size. Right? And we will always have equal sample size in a one-way repeated ANOVA, because in order to be included in the analysis, you must have been tested in each and every group. All right. You can ignore this where it says multivariate test. We were only looking at one dependent variable, so we don't need to look here. You do want to look here. This is Mauchly's test of sphericity. Now, there is an assumption when you run a one-way repeated ANOVA that you have a condition called sphericity. I'm not going to go into detail here what sphericity means, but what you need to know is that you want this assumption to hold true. You want sphericity, which means that you're going to test it, and you're going to test it using Mauchly's test, and you do not want that test to be significant. I know this seems weird because most times we're looking for significant effects, but whenever you test an assumption, you never want the assumptions to be significant. So we're going to go here and we're going to look and see whether or not we have or don't have sphericity. And so here we have Mauchly's W, but the really important thing here is to look at the sig value. And the sig value is the same thing as the p value. SPSS just calls it the sig value. And it's less than 0.05, certainly less than 0.05. So it's significant. Now again, are we happy or sad about this? We're sad, right? We don't want this test to be significant. Why? Because we've just learned we have a violation. When have violations ever been a good thing? Never, right? So because the test was significant, we have a violation. We're not too pleased with that, but never fear. With this particular test, SPSS will correct for the violation. All right? And I'll show you how that's done over here, or where to look. So this is actually the ANOVA Table. All right? This is where you're going to get the results of your analysis of variance. Now, you're going to look, because we have a violation, you're going to look at the data where it says greenhouse geyser. That's the name of the correction. Let's pretend for a second that the test up here, let's pretend that it wasn't significant. Let's say that this sig value is greater than 0.05. That would make us happy. It means we have no violation, right? It means we've got the assumption. We've satisfied it. If that's the case, then when you look here at your ANOVA table, you would look at sphericity assumed. All right, and you would read off the degrees of freedom. That's the degrees of freedom for the independent variable that you're testing. So we have 2 degrees of freedom. But when you run ANOVAs, you always need to report 2 numbers for degrees of freedom. Here's the first one. And the second one you report is for the error term. So again, you would look at error, and you would look at sphericity assumed, and here are the degrees of freedom. So the degrees of freedom, if you have sphericity, are 2 and 114 in this particular example. Unfortunately, we determined that we do have a violation, so now we're going to look at greenhouse geyser. And you're going to look here, so belief category, greenhouse geyser, the degrees of freedom have been corrected. They've been reduced. All right. That typically is going to make it harder for us to find significant effects, but that's what you pay, right? The price you pay when you have a violation. So this is the degrees of freedom for the independent variable, but remember you have to report two, so you have to go to the error area here, and you look under greenhouse geyser, and our degrees of freedom are 72.651, considerably less than the 114 had we not had a violation. And again, typically that's going to make it more difficult to find significant effects in our ANOVA. Now, you have to look at what what the journal requires in terms of how many. Can you just round this to 73, or do you have to report it to 2 decimal places? I mean, if you're doing this for a course, what does your instructor want you to do? So you need to find that out. Maybe you're going to have to report it to 3 decimal places. That all depends on who you're writing this for. Okay, so we've got our degrees of freedom. Next, we read over the F value. So the F value did not change. It's 17.26. We're going to round. Had we had sphericity, it still would have been 17.26. And in this case, it didn't change the sig value either. It's 0.000, whether you do the correction or not. So even though we had a violation, and even though we had to run it looking at the corrected data, the outcome was the same. That's good news. We still have our significant effect. Then we can look over here, and this is partial eta squared, which is a measure of effect size. Essentially, what it's telling us is how large an influence our independent variable has on our dependent variable. So it's telling us that the category, the belief category, angels, demons, and ET, has a very large effect or influence on belief scores. Now, at this point, all we know from the ANOVA is that we have a significant effect, but we don't yet know which mean is different from which. All right, remember that to find out that information, we need to run another test, and it was the post-hoc test. And so now we need to find the results of that post-hoc test to find out which means are different. Ignore this box here and ignore this one. We're going to go right to where it says belief category, right? And here it's telling us the means and the standard error of the means and the confidence intervals in case we want that information. Now, normally you don't look at estimated marginal means. That's the case most of the time, because most of the time we're going to have different sample sizes in each group. But with a repeated ANOVA, remember, it's the same people in each group. All right, so if you're in this study, you're going to be in the angels category, the demons, and the ET. So the sample sizes are going to be the same. So we can look at the estimated marginal means and get accurate information here. All right. But to get the post-hoc, we look right here where it says pairwise comparisons. And here you have to do you have to play a bit of a memory game. What was level 1? Well, that was angels. What was level 2? Demons. What was level 3? ET. I wish that SPSS would actually show the labels rather than the numbers. But, that's where my wishes don't come true. All right, so to see if angels are any different, significantly different than demons, we're going to go here, 1 and 2. So we're just going to go along this row until we get to the sig value. And we can see that the sig value is 0.022, which is less than 0.05. So we now have learned that angels and demons are not the same. They have significantly different means. We don't know which mean is higher or lower unless we look up here. So we can see, since these two were significantly different, we can now say that belief scores are probably lower for demons than they are for angels, which I guess makes sense, right? Like, I would rather believe in angels than demons, personally. That's just me. All right, what about angels versus ET. Now you have to go a little bit on the diagonal. So angels and ET, and just go over here until you get to the sig value. And again, we see that the difference between those two means is significant. So that means that this mean here, this is mean for angels, is significantly higher than the mean for ET. So belief scores probably are higher for angels than they are for extraterrestrials. All right, now there's one comparison we haven't made, and that's between demons and extraterrestrials. So again, we're going to look here, 2 and 3, and we're going to go along the row until we get to the sig value. And once again, we've got a significant difference. So this tells us that the difference between belief in demons is significantly higher than the belief in extraterrestrials. All right? So we would conclude that belief scores probably are higher for demons. Now we asked for a graph. Ignore this. We asked for a graph, so here we go. And remember, normally we wouldn't look at anything that said estimated marginal means, but when you have a within subjects design, these means are going to be accurate because the sample size is the same for each one. And so what we can see are significant differences between each of the means. None of the means showed a non-significant difference. Every mean was different from every other mean. So belief in extraterrestrials, that's the lowest belief score. Okay, so people believe the least in extraterrestrials and believe the most in angels. Okay, well, that's it. I hope you found this video useful. If you did, please don't forget to hit that like button and check out some of my other videos. All right.